Rationalizing the denominator is the process in which the radical in the denominator is removed. So when you're asked to rationalize the denominator, you're just trying to get the radical out of the denominator, just trying to get it to go away. So we're going to rationalize the denominator of each expression, but we just got to remember what a cube root means. So a cube root of x, for example, is just x to the 1/3. And what I'm trying to do is I'm trying to get this 1/3 to go away. So to do that, I need to make it like 3/3. So what do I need to add to 1/3 to get it to be 3/3? And the answer is 2/3, because I need to get x to the 3/3. That is my ultimate goal, is to get my cube root to be 3/3 so it goes away. So when I have 1 over the cube root of 6, I can just say that this is just 1 over 6 to the 1/3. Now what do I need to add to 1/3 to get 3/3? Just like over here, I needed 2/3. So I use my knowledge that I need the same base of 6, and I'm going to multiply it together. So when I do that, I'm going to get 6 to the 3/3, which is just going to be a 6. But I can't just do that to the bottom. I have to do it to the top as well, because I need my expression to be balanced. So I'm going to multiply the top by 6 to the 2/3 as well. So when I do that, 1 times 6 to the 2/3 is just going to give me 6 to the 2/3. And the bottom, I'm going to get 6 to the 3/3, which is good, because 6 to the 3/3 is just going to give me a 6. No denominator, or the denominator no longer has a radical in it, so I'm happy. It's rationalized. But I can rewrite the top. I can take my denominator 3 here in the index and call it the index up here. So it's going to be the cube root of 6 squared. And then I can work out 6 squared as 36. So 1 over the cube root of 6 with a rationalized denominator is the cube root of 36 divided by 6. Next, I have the cube root of 7 over p. I don't have a denominator just with a radical symbol on its own, so I'm going to separate these two as the cube root of 7 over the cube root of p. And since I don't want a square root, you don't need to do this, but I like to do it just because I can see it a little bit easier. I can rewrite p as p to the 1/3 instead of the cube root of p. And now what do I need to multiply p by? What do I need my exponent up here to be? I need to multiply it by 2/3, so I can add them together. But again, what I do to the bottom, I have to do to the top to keep it balanced. So multiply the top together, I'm going to get the cube root of 7, and I'm going to rewrite this as the cube root of p squared. So just move the denominator in front as the index and keep it like that. And then p to the 1/3 and p to the 2/3 is just going to give me p. And since these are both cube roots, I can multiply them together as 1. So the cube root of 7p squared over p. And here is this expression with the denominator rationalized. Last, I have 2 divided by the cube root of 20y. So I'm going to rationalize this, but I'm going to change the form just so I can make it a little bit easier to see. So I'm going to say 20y to the 1/3. And what am I going to multiply this by? Because I need this 1/3 to be 3/3. I'm going to say 2/3 again. And just like before, I do the same thing to the top. 20y to the 2/3. Now I can distribute the 2 over, multiply these two together, and I'm going to end up getting 2 times, and I'm going to rewrite this as the cube root of 20y all squared. And in the denominator, I know the 1/3 will make it 3/3, so I got a 20y. But unlike the others before, this one we can do some simplifying. 2 can go into 20. So when I do that, I'm going to get the cube root of, and 20y squared is just going to be 400y squared. And then 2 into 20 is 10, so 10y. Now this is where you'd like to think you're done, but unfortunately, we're not, because 400 can be broken down. 400 can be broken down to the cube root of 8 times 50y squared over 10y. And so the cube root of 8 is going to give me 2. And then I can rewrite the rest as is. So the cube root of 50y squared over 10y. And again, just like before, I can take 2 and divide it into 10. So I'm going to end up getting the cube root of 50y squared divided by 5y. And now, finally, this is my simplified solution.